Welcome to Main Street Minds with your host, Amish Munshi. This is where industry leaders and seasoned pros share their secrets to success beyond limits. Let's dive in.
Hello and welcome to Main Street Minds. Today we have a very special guest, Shyam Sharma, over here with us, local over here in the Bay Area. He studied at IIT Kanpur and is currently working in the Silicon Valley in a very successful company and wanted to share what does it mean to be successful in the IT field. So without any further delay, Shyam, go ahead and introduce yourself.
Yeah, thank you, Amit. And yeah, my name is Shyam Sharma. I'm working as a distinguished engineer at Cadence Design Systems. I've been in this field for more than 25 years now, since my IIT Kanpur days. I guess I was the last generation from the millennia. So I passed out in 99. So yeah, more than 25 years now. And
Yeah.
my primary area of focus is really semiconductor and memories.
Mhm.
I mean, specifically on memory side, memory subsystems and the latest generation of storage. And yeah, I'm based here in San Jose.
Yeah, that's great. So how did you get started? Like, were you always interested in IT?
I was interested in, and I did my engineering in electrical, which kind of covers electronics as well as I did a minor in computer science. And so it basically encompasses the electronics, electrical, and computer science overall. So I mean, I was interested in all the three fields, but yeah, electronics was really the core that I really was interested in. And my first company was actually Mentor Graphics, which has been acquired by Siemens now. And there, my primary area of focus was on processors, the RISC processors, like Power PCs and
Mm-hmm.
those kind of things,
Yeah.
which
Yeah, and I always wonder, like most RISC processors are able to do everything, right? Like, why do we need that extended set of instructions? Like, if a RISC processor is able to do all that same processing, is that like if you can, I don't know if you have an answer or like why does it even why do we need a more extended instruction set that's slower versus things? I think things perform faster, right, on a RISC processor.
Yeah, the main advantage of Frisk is that you can actually customize it to your needs, right? You are not stuck with a fixed defined set of instructions really that you need to, which is what GPU, I mean, difference between GPU versus CPUs are, right? CPUs are more general, right? It
Mhm.
applies to everything. RISC processors, you can really fine tune it to whatever application, the target application that you intend to use it for, to optimize it to just that particular need.
Mhm. Makes
So
sense.
yeah.
Yeah, that makes sense. So, so how did you transition from that into more of memory and semiconductor? Like both are semiconductors, but still within that from there to memory.
Yeah, I guess they kind of go hand in hand. You have to like CPUs and GPUs, they need to work with the memory to really optimize. In fact, I mean, if you look at that's where crux of or where the bottleneck really is. Like if you currently see um, the reason why CPUs and GPUs have gone far ahead, but memories has not really gone to or has improved to the same order of magnitude really. That's why some people really say that we are in this memory wall issue that we are
Mhm.
running into, where uh, the lack of IO is really what is not really able to match up to the requirements that we really can do if we were to
Yeah.
just so
And
so yeah, they go in hand. So yeah, both the areas are equally interesting.
yeah, and I always wondered like it is possible to have faster memory, right? But like is it like just the distance from the separation or the interface? Like because if we compare the cache memory that's within the processor, that's extremely fast. versus
Yeah.
on a RAM. It is also really fast, but like what causes that big gap?
Yeah, so the cache itself is faster, obviously, and it has also evolved. But cache, as you know, it's very limited. You only
Yeah.
can store very limited amount of data in a cache, and then you need to go to the next level of memory, and
Mhm.
that's where the DRAMs and other fast memory technologies really come into the picture.
Mhm.
That's where majority of the uh, focus, along with the GPUs itself, that's AI revolution is really driving into. So, I mean, and it has its own set of actual, limitations on the silicon itself, which is
Mhm.
really causing this to
Okay.
get more pronounced as we are into, as the requirement for bandwidth and densities are increasing exponentially.
Mhm. Yeah, yeah.
So,
And yeah, so overall, like what are some of the new emerging things happening in the memory space?
yeah, so memories, I mean, the DRAM itself is pretty dynamic,
Mhm.
whether it's the low powers, the server class DRAMs, or, graphic DRAMs, or the bandwidth memories, which is really a major focus area now.
Mhm.
So all of those are evolving, and then there are multiple new technologies that different companies are working on, whether it is MRAM,
Mhm.
high bandwidth uh, flash memories, some companies are trying on. So, I mean, but yeah, a lot of focus is on the DRAM itself. And as you might have seen, a lot of these memory vendor companies, I mean, their profits are going exponentially up just because of
Yeah,
the kind of demand, whether it's SK Hynix or Samsung. I mean, these are really making and breaking companies in that sense.
yeah, yeah.
So,
And is it just a very high demand right now, or there was also like more on issues on the supply side? Like right now, I think it's very, very
yeah,
expensive.
yeah, they are actually kind of related, right? Because of the demand itself,
Okay.
there are constraints on the supply. You can't really catch up, and that is true even for the GPUs as well. But it is more pronounced on the memory side,
Mhm.
So it's all interconnected, really, in that sense.
Yeah, yeah, makes
Uh,
sense. Yeah, so tell us a little bit more about you, like the whole journey. Like what was it like to work on the processing side versus the memory side? Like tell us a little more about your journey. Like in it, along with the technology, along with that, like if somebody is trying to make a successful career in semiconductors, how should they approach it, and like how you approached your career to go through that transition and become successful.
Yeah, so I mean, starting with basics are really important. I mean, you
Hmm.
have to obviously start there,
Hmm.
but the field itself is evolving so fast that, just to catch up, if I were to really give examples for like by the time your actually standards come out for these new memory
Hmm.
technologies, it's too late. I mean, there are companies who already have hardware available for initial versions of it, obviously, but
Hmm.
so it's like a catching up game, really. So you have to be ahead on all the time on
Hmm.
your toes, really, to keep focused on what is going on. Learning is an important part. You obviously can't know everything,
Hmm.
so reading and thinking long term, that's
Hmm.
really what in the end, that's what matters.
Yeah, yeah. And so how was the transition like from IIT Kanpur? Like the first job itself was with in like how did you get started with the
Yeah,
first
so
job?
I was really young when I started my first job. I actually was younger than 20 years, actually.
Hmm.
So I turned 20 on my first job. So
So
that,
it's like second or so was it second or third year of engineering then?
no, I actually did complete engineering in June, and
Okay.
yeah, so my birthday is in September, so
Ah, that's right.
just
Okay.
few months difference,
Yeah.
but
Sweet.
yeah. So and then obviously, I mean, at that time I was too young to really uh, have detailed career plan as most of the fresh graduates are.
Hmm.
But I guess once you start to see what is going on, and then that's what shapes up your career. So few years down the line, then I knew that this is the field that I really want to make a career out of it. So
Nice. Yeah, that's pretty cool. So, like, let's say somebody is new right now. You did mention that they should be focusing on the basics, but like, how do they make like, like, because I mean, I've done software, so it feels a little more natural to me where I can like just put some software and like try and experiment with it, right? But how does somebody make a get real exposure in semiconductors?
So I think nowadays, as compared to what it was 20 years back, you have lot of good content online. You have lot of trainings available.
Hmm.
There are a lot of people who are actually putting up good content, whether it is LinkedIn Learning,
Hmm.
YouTube, Coursera. There are a lot of and many universities even now they provide free online uh,
Yeah.
classes, videos, their own tutorials that are available for you to actually. So the motivation to learn is really what what
Yeah.
you need to have.
Yeah.
So
Yeah. And I think even the direction, right? So in today's world, I think the it's more of an information overload. Sometimes it's like
yeah.
there is too many options. So I think that's so you thanks for shortlisting some of them that are really good.
Yeah, of course. And yeah, I mean, of course, we are in the AI era now. I mean, it's
Yeah.
really a paradigm shift for everything. So people have this conception that, only the white collar jobs are really going to get affected by the AI revolution, but that's not true. Even blue collar or other types of jobs that are there, I mean, those people also need to learn new set of skills on their tools are going to change, how those are going to be used. Those, there's no aspect of life that's going to be remaining same in 5 or 10 years down the line. So
Yeah.
absolutely, you have to. Yeah. It's not that something that is happening later in the future. It is happening right in front of our eyes.
Mm.
Every day we see a new application. It- I mean, it's like endless opportunities, really. So.
Yeah, that's true. So coming back to kind of your profile, like where do you see yourself? Like what are some of the things that are driving you, making you motivated to like keep working, and what do you like to do, and where do you see yourself in 5 to 10 years?
Yeah, so as I was initially indicating, I mean, uh, learning new things as well as, solving the real world problems. I mean,
Hmm.
that's where uh, that's the interesting part of the job itself, right?
Yeah.
AI applications, how those can be leveraged for everyday work that we are doing. I mean,
Hmm.
uh, it's an endless possibility. That's what, as I
Yeah.
already mentioned, right? So those are what I mean. There are a lot of things to be explored now with the right set of tools that we have
Hmm.
now. So I think uh, the type of jobs that we are going to do 5 or 10 years down the line, even few years down the line, maybe not even five, will be kind of different then. So,
Hmm.
that's what is exciting part of
Yeah.
this.
So within your specific work profile, like how are you seeing AI enabling you to do more? Like what are some of the things that you have to do where you are seeing AI being available, providing more meaningful
So
value?
it's everywhere, whether it is the chip design, verification of those, or just the everyday code that you work on.
Mhm.
Those are also it's lot of not just the productivity improvement, but
Mhm.
also paradigm shift in the sense that how you are really approaching the problems, right? So
Mhm.
chip cycles or those are going to get shortened by the kind of tools that we have access to now. Whatever used to take 5 years previously or 3 years previously can be done in a year if you
Wow.
that's the kind of thing that
Yeah.
will happen. So and lot of so there are the data center side of things where a
Mhm.
lot of it is centralized, but a lot of it is also coming on your edge devices, whether it's the cell phone, whether it is your smartwatches, everywhere. So I think it's a revolution in that sense, really.
Yeah, exactly. So that does make a big difference. So yeah, and so as we come closer to the end of this episode, I always like to ask like any other pieces of advice you would like to give to somebody that's trying to make a good career in tech, right? In general, like it may not be semiconductors, but in general, how should they approach a long-term career so that they can be successful?
Yeah, I think there's no shortcut to hard work. I think that's my main
Yeah.
take from this. And I know there are a lot of options to learn. So
Hmm.
knowing what you really want is actually, that is half of the battle done.
Yeah.
So once you know what are your interests, whether well, it could be anything within the tech. It's such a vast domain, and
Hmm.
and the real life application of it, you see, is what will give you motivation. That yeah, it's not a theoretical thing. It is being used in everyday things that you do. So
Hmm.
that's what you should always try to correlate it to how this whatever you are doing is actually making an impact at the
Hmm.
end of the day.
Yeah, that's really cool.
Yeah.
So yeah, as we come to the end of this episode, wanted to open up the floor and like anything else that you would like to share, please feel free to share with the audience.
Uh, I mean, I'm really happy to be on the podcast itself, and I have my LinkedIn profile up in case if anybody
Sure.
has any questions. I mean, feel free to reach out. I'm always happy to talk to people.
Yeah.
So, yeah.
Thanks for being available, and it's really good to like being able to like reach out to someone as experienced as Shyam and being available and him being available to actually answer something that you might have a question about. So thanks a lot, Shyam, for coming on Main Street Minds.
Yeah, thank you, Amish. Yeah.
Thanks.
That's a wrap on today's episode of Main Street Minds. Want to share your journey with our audience? Head over to mainstreetmindspodcast.com/guest to apply.